ago, when we were working on a different section and I first started Unit 4, I said, hey, I'd like you to graph this equation. Y equals 1/2 x plus 3. Okay? And the only way you knew how to graph that was by making a table of values, right? Man, we worked with tables for a while, okay? And a table of values, if there was no domain restriction, right? Remember that one where we had domain restrictions? With no restriction here, you got to pick whatever numbers you wanted for your domain. Now, whatever numbers you're going to put in here, you got to take half of it. I want to take half of an even number. And I want some positives and some negatives. So I'm going to choose those 3 numbers. Remember that? And then look what you had to do. You had to plug -2 in here and say half of -2 is -1. -1 plus 3 is 2. Half of 0 is 0 plus 3. Half of 2 is 1 plus 3. And then you had to plot those points, and that's kind of a pain in the butt, isn't it? Okay? Let me tell you what. Today is the shortcut on how to graph a line with no table whatsoever, because all we're going to be doing for about the next 5 weeks is graphing lines on pieces of paper. And if you have to make a table of values every single time you want to get a line on the graph paper, you're going to be here forever, and you're never going to finish. So look what we had to do. We did -2, +2, then we did 0, 3, and then we did 2, 4. And we had our line graphed. And then we took our ruler, I'll get you some rulers today, and then we graphed this line, and we put arrows on both ends, and after about 4 minutes, you finally had that line graphed. Oh, pain in the butt, right? So, today, we are saying no to table of values, and we are graphing using Slope Intercept Form instead. Okay? Guess what? A table of values is a really good fallback. Do you know what that means? If you maybe forget how to graph, could you check it with a table of values? Yes. But there are kids that I taught this to in my FlexPace course where I was like, you have got to learn how to do it. And they were like sneaking like table of values in on the side. I'm like, no, you don't get to do that. You have to use a shortcut. So let's talk about the shortcut. Remember what we talked about a couple days ago? Guys, back table, please listen. On the graphing calculator, we learned what that number does. Do you remember? What did we call that number? It's the B. And we call it the what? The what? The beginning value. We call it the y-intercept. Thank you. And so that line, this point, was defined as where the line intersects the y-axis, which is right here. Agreed? Which is also in our table, just for the heck of it, right there. So look at those 3. That 3 is here. In the table, it's with 0. Good? Then I said, hey, M stands for where you move, right? So I might write the word begin here, and I might write the word move here, keeping in mind that you move with rise over run, right? So if I'm keeping my pencil on the y-intercept, I don't go back to 0. I keep my pencil here, and I go up 1, right 2. Got it? Because it's positive. And look, it happens. There's my up 1, and there's my over 2. I don't really need this point, do I? I need to see 2 points on your graph. Your y-intercept, and then your next point. Got it? Okay? So let's try an equation like this. Y equals -2/3 x plus 1. Okay? Y equals -2/3 x plus 1. Where am I going to begin? Right here, plus 1, which is right here. So if you are a highlighter person and you have your own highlighters, this will help. I'm going to put a point right here, and then look, I'm going to keep my pencil on that point. Here's another way to explain slope. Like MapQuest. You ever have to punch in an address, right? And it tells you, go down to this street, turn left, then go to this street. These are your directions. Your friend is telling you that if you live at this house right here, and these are all streets in this little neighborhood, your friend lives 2 streets down or south and 3 streets over east of you. So if I were to go from here to get to my friend's house, I'm not going to go up 2 and right 3. I would go down 2 and right 3. So those of you who put that on there and went up somewhere, you are not taking into account that that is a negative slope. Okay? So here is your down 2, and here is your right 3. And those are the only 2 points you need to plot that line. And you have arrows on either end. Does that make sense? Down 2, right 3. Now, I'm going to give you a big bit of advice. When you're plotting, try not to run to the left. Meaning, if you're either going to go up and right for positives or down and right for negatives. There's going to be one time where you have to go left. I'll show you in a minute. Are you good so far? Like if you know how to plot these quickly, you can plot like 20 of these in like 3 minutes. Like seriously, if you know what you're doing. Okay? Let's look at this next one. Y equals 2x minus 4. My beginning value is minus 4. Highlight it if you want and go to negative 4 and start there. Okay? Keeping your pencil on negative 4, you go to look at the slope, but you don't see a fraction. And it's really weird because you never thought to yourself, man, I wish that was a fraction. Usually we are wishing away the fractions, right? So I need to know, is 2 my rise? Is it my run? We'll make 2 a fraction. By doing what? Now my rise is 2 and my run is 1. So anytime you have a whole number, that's going to be your run is 1. Try to say that 3 times fast. Your 1 is 1. So from here, I'm going to go up 2 over 1. And you know what? Just because we have room for the heck of it, let's keep doing it. I can keep going up 2 and over 1, up 2 and over 1, and I can get a really good sampling of points. I really only need 2, but this isn't going to hurt. That way, sometimes your ruler's off a little bit, and you get a sloppy line that doesn't really, go through your points. Are you good so far? It's not that bad, huh? All right, let's look at this next one. Y is equal to just x minus 3. So I know by now, where do you begin? You begin at negative 3. I don't see a number anywhere. Where do you go? What's the number in front of x when there's nothing there? Uno, yes. And now I need a fraction. So your slope is going to be like a little staircase, up 1 over 1, up 1 over 1. That is your slope every time it's just x. So I'm going to go up 1 over 1. Technically that's enough, but I can keep going. Okay? Hey, for the heck of it, what could I do to get some points on this side of the graph? Instead of up and right, I could go down and left. Now that would be okay. You don't need to do it. I'm going to show you a minute when you do need to do it. So just get as many points as you want. 2 is enough, but this gives you a really good line. Cruising, yes, thumbs up, keep going. All right, this is the easiest one of all, if you can remember. First thing, hopefully you think is, oh, that's y equals 5. And Mrs. Z said, hoi, remember? H-O-Y. Oh, that's the y equals 1, when there is no x. That means it's a horizontal line with a slope of 0. So where do I go? I go to the y-axis at 5, and I draw a horizontal line. Okay? Yep, horizontal is left to right. Okay, yeah, some people, you guys are going to get these confused. Now, if you forgot that, guess what your fallback is? You go, oh, I don't see an x, which must mean there isn't any. So that 5 is really my what? Y-intercept. And from there, what's my rise? 0. What's my run? 1. Go up 0, over 1. Don't go up or down, go over 1. Got it? That's your fallback, okay? Which then takes me to this. You shouldn't need a whole bunch of explanation for that one. You remember the only time that you have it being an x equal instead of a y equals, that makes it not horizontal, but what? Vertical. So where do I start? There is no y-intercept. This is parallel to the y-axis. I go here. You want to know the biggest mistake kids will make? They'll go to negative 2, and then they'll draw a horizontal line. I'm like, oh, so close. X equals is a what? Vertical line. Every single X value on that line is -2. So what's the name of the equation? X equals -2. It's really as simple as it gets. Okay? I'm going to keep going if you're with me. And is a lot of this a review maybe? Yeah. Okay, stay with me. Y equals -x plus 2. 2 points, all I need. Where do I begin? Plus 2 on the y-axis. Where do I go from there? Ben. Good. Down 1. When you say over 1, I'm assuming you guys mean right, correct? Yes. So I'm from here going to go down 1, right 1. Down 1, right 1. And then that's your line. Okay, look how fast we're going through these. If I had to stop and do a table of values for every single one of these, we'd still be on like this one up here. You agree? Okay? So much easier. It's a shortcut. Shh. All right. Now, you can avoid it for only so long. You're going to get to a graph like this, and it's going to say, graph that line. And right away, what do you notice? Bummer. It's not in slope intercept form. Slope intercept form is the easiest way, the quickest way to graph a line. So, do you know how to get it into slope intercept form? Yes, I taught you. So do that right now, please. Take a minute to get that into slope intercept form. Okay, just like in the homework from yesterday or Wednesday or Tuesday. And then you have to divide everything by -3. And that's going to give you a positive 2/3. Put your x in the middle. What is your y-intercept? If you solve for y incorrectly, your graph is automatically going to be wrong, right? Okay, so I'm going to start at 3. And I'm going to go up to over 3, and that's all I need. Okay, flip your graph paper over, because now we have to talk about some problems. Shh. Okay, all right. If I asked you to graph, are you listening? Because I know that other stuff was easy for you. Y equals 4/5 x plus 4. Just go ahead and see what problem you run into. Yeah. That's inconvenient. What happens? You plot your 4. Shh. When you go to rise 4 and then run 5, there's not any room to rise 4. Let me show you what I don't want. I literally had kids create with rulers, and it took them like half their test, whole new like 5 sections of a grid. Like it looked so neat, but they didn't finish their test, but man, their made up graph was perfect. No, don't do that. What's the alternative to rising up 4 and running right 5? Going down and left. So here's what you could do. You could say, well, if there was room, my point would be maybe somewhere over here, which means my line would be going this way, which means to get another point over here, then I need to go down 4 and right 5. Okay, that works. I don't want a point out in outer space. I want your points to exist on the coordinate plane that was given, and that's the only way to do it. Got it? Okay? So I would like you to try this one. Y is equal to -3/4 x minus 4. Try that. What are your options at that point? So, first thing you need to notice is that there's a negative sign in front of that x coefficient. So your line had better be going down from left to right. If you went up 3 and right 4, you're going to probably get a 2 on this next test. Because you've got to, and it's probably the same one that you got wrong on standard 8. You've got to get your negative slopes in line, right? So I'm about to go down 3 and right 4, but I run out of room. I know I'm going to be somewhere over here, which means I know my other point's going to be somewhere over here. So instead of down and right, could I go up and left? Yes. Up 3, left 4. Make sure that you have a little dot right under your negative 4. And if you do, then you are doing your rise and your run correctly. 1, 2, 3. That's what you're supposed to do. Yeah. All right, are you good with that? Graphing. All right, ready? Shh. Have you heard of if-then statements? Okay, an if-then statement would be if it's 1:47 on a Tuesday, then most kids should be in school unless it's a holiday or whatever, right? Okay. If I am my mother's daughter, then my mother is my mother, or like if-then statements, right? If a shape has 4 sides, then it's a quadrilateral. Could you say that backwards? If a shape is a quadrilateral, then it has 4 sides. So I want you to come up with, first I need you to stop talking. Oh, wait. I want you to come up with an if-then statement for these 2 lines. Y equals 1/2 x minus 4 and y equals 1/2 x plus 3. So you might be able to give me the if-then statement without even having to graph them. How many of you kind of know what I'm looking for right now, and you haven't even had to graph these 2 yet? Okay, let's graph the purple one with purple. I'm going to go down to 4, and I'm going to go up 1 over 2. And just for the heck of it, I'll throw a couple more in there. I might even put a couple more this way. So, because I want a really straight line. Okay, you're going to see why. I'm going to make sure my ruler is really on those points. Then I'm going to pick up my pink, and I'm going to go to plus 3 here. And I'm going to do up 1 over 2 again. And maybe put a couple this way just to make sure I get a really good line. And when I graph them, yes, I heard somebody whisper it. They are what? They look at least. They are parallel to each other. Maybe my ruler was a little off. It might look like they might eventually meet down here, but how do I know for sure that these 2 lines will never meet?
They have the same slope.
Okay, can you write an if-then statement now? If blank, then blank. Try it. Write it on your paper right now. If, then. If 2 lines blank, then they are blank. Anybody start with that? If 2 lines have the same slope, which by the way, 1/2 and 1/2 are the same slope, then what? You can guarantee every time what, Declan? Then they are parallel to each other. Can anybody write the converse of that? This is a geometry thing. The converse of that is just saying it backwards. So if 2 lines have the same slope, then they're parallel. Converse is if 2 lines are parallel, then they have the same slope. I don't care how you say it. Just know that. Okay. So if I were to give you, which I will, sorry you're listening, we're almost done. If I were to give you 2 points and say one is -1, +1, actually -1, -1, let's say, and 2, 0, and call this line A. Then I were to give you point 0, -3 and 5, -1 and call this line B and say, are these two lines parallel to each other? What could you do to figure it out? Here's what we could do. If you happen to have a piece of graph paper handy in your pocket, you know, if you're working somewhere, you could plot those 2 points, connect them, and see if they're parallel. But if you do that, then the way you hold your ruler, even to like a millimeter to the left, could affect what looks like it to your eyes. So what's a safer route to figure out if these two lines are parallel to each other?
Stacking them.
Yes, either stack and subtract, or Mr. Gill method, or use the formula. So watch. Shh. So I could say, keep your y's in the top, 0 minus -1 over 2 minus -1. All right, line A has a slope of 1/3. If line B also has a slope of 1/3, guess what? They're parallel. I want to remind you that some people don't like doing it that way. Some people prefer the table. Remember that? So if my x is 0 and my y is -3, and my y here is 5, x is 5, and my y is -1, how many of you prefer doing it that way? The change in x, whatever you want to do. What is the change in my x? I'm going from 0 to 5. What is the change in my y? I went from -3 up to -1. The y over x, my slope is what? 2/5. Are these lines parallel? No. Watch what happens if I were to plot them. Shh, almost done. -1, -1, 2, 0. Okay? I'm going to do something on purpose.